Hi, and welcome to a very short sound design lecture. Here we will be dealing with the constant source node in the Web Audio API. And the reason why it's so short is because the functionality we're discussing is the simplest audio node in the whole of the Web Audio API. Constant source node simply generates single channel audio with constant output. So it has one parameter, offset, that determines that constant value, and it defaults to 1. So if you just start a constant source node without changing any parameters, all you are getting from that node as output is a constant stream of one track, one channel. Yet it's a very useful node, one that appears over and over again whenever you're implementing large things with lots of nodes and a big complicated audio graph. So if you connect a constant source and another node to a gain node, then the constant source acts like an adder. It simply adds that value to whatever was the other node. Similarly, if you connect a constant source to the gain parameter of a gain node, then it acts like a multiplier. But you don't really need the constant source to do that, because you could have had just the gain parameter directly modified to multiply. And another thing you can do is set many parameter values for many nodes with one constant source by connecting the same constant source to each of them. Now that's quite a powerful thing. We're going to use that quite a bit. It's what's done in grouping and subgrouping when doing audio mixing tasks. So if someone is recording a band and they want to audition what the levels are just from everything that's mic'd, every microphone connected to the drum kit, then they can group all of those sources together, mute everything else, and apply one gain value for all of those sources together. If someone is mixing and wants to change the level of, say, all of the backing vocals, and there's multiple backing vocals, one can group them together or apply one single gain control over all of them. So all of that sort of work is part of subgrouping of audio during mixing. And it's done all the time. People might want to change the level of the drums in respect to everything else, and they might also want to just produce a mix just of the drums. So ignore everything else, but concentrate on the separate elements within the drum mix. Or change that level of drums in comparison to guitar, bass guitar, vocals, and anything else that's in the mix. There's plenty of other uses for the constant source node, not just controlling parameters in mixing. You might be generating a particular pitched note and want to change the relative levels of the harmonics. So have the constant source apply a gain to many different individual frequencies. Or have a constant source affect stereo panning and gain at the same time. So for instance, whenever a sound comes in that's very loud, it moves over to the left. Maybe you're doing some fancy creative spatial audio there. So that idea of controlling multiple parameters is one of the beneficial uses of the constant source node. And it also allows you to do math and math within your audio graph, because as mentioned, the constant source can act like an adder, adding a constant to a signal, or a multiplier, multiplying the signal by some constant value. And I keep saying constant, but you can change the value of the constant source's offset over time. You can have an exponential ramp, a linear ramp, resetting the value, and so on. So it can act very dynamically. So let's look at a single example here. Now, it's a toy example because the type of thing we're doing can be done, is quite useful to do. But because we've simplified it so much, you don't actually need a constant source node to do it. And what it is, we're going to load in multi-track music. So the individual tracks the individual sources that make up a mix are going to be on separate files. And we're going to load multi-track music here and use the constant source node to control the level of several of those tracks at the same time. So we might specify that guitar and vocals will be modified together, and we'll use one constant source node to change a gain applied to both those tracks. In this case, we take a multi-track from what is known as the Cambridge multi-tracks collection, and it's a large number of Creative Commons multi-tracks that you can use for research and education. And we take one of them and we take a few tracks from it, congas, bass, ukulele DI, where DI stands for direct input, so the ukulele is going into the mixing console, and ukulele microphone, where we're getting what the microphone picks up next to the ukulele, so much more the acoustic sound, and a viola. And so we're dealing with 5 sources, and we're going to select some number of sources. That's what the user can do on the user interface, and with a single slider change the volume of several sources together. That allows you to audition. Oh, how would this sound if I just hear both the ukuleles? How about if I take the direct input out? How does it sound if I just listen to the most percussive elements, and so on? And so this sort of thing enables some grouping functionality by turning on or off, or combining together several different channels within a mix. Channels in that case is not stereo channels, it's channels as in a channel strip on a mixing console. If you're doing it all offline, think of it as the tracks. Okay, so let's see how this works. I showed you this sort of block diagram here, but now let's have a quick look at the code. So just making it so it's easy to read the code. Okay, so first we have the HTML on my left. I think you'll see it on your left as well. And we have the JavaScript on the right. I think it's going to be good to explain it if I first show you what it is we're trying to achieve. So this is the interface that we are creating in HTML. We're going to have 5 tracks. We select them and we change the volume on them. We only change the volume on the ones we select. So that's the idea. So now let's look at the code. If I look at the HTML, I create 5 checkboxes, each with a name associated by it. And when it's clicked, I go to a function called checks, where it takes the name of that checkbox, check 0, check 1, check 2, etc., as the input to that function. Then I have a range control, which I'll use for the volume, and a play button where we resume the audio context if it's not already on. So now let's look at the JavaScript code. Well, I have all these checkboxes, but I need to load these 5 tracks. I have them in the same folder as where the JavaScript and HTML files are, but how am I going to deal with them? So I have the 5 tracks by file name, and they all have the .wav extension. So what I'm doing here is I save the 5 files as strings, where I take the name plus the .wav extension. Then I say I'm going to create my tracks as audio nodes, and specifically media element source nodes, or media element audio source nodes. And we've used that before. It's whenever we're basically just reading in an audio file. And I'll create 5 different gain nodes for each of those tracks. I connect the tracks to the gains and the gains to the destination. So I basically just built the graph that you saw in the slides here, this block diagram, although I haven't put in the constant source part yet. And single destination, and what else to note? These gains here are initially all set to 0. So even with everything connected, it has 0 level output, so you wouldn't hear anything. Okay, then we create a single constant source node that we just call constant node. We set it to start, and initially it has its default offset, which is an offset of 1. Whenever the volume is changed, we change the constant source node's offset to the new volume level. And when the play button is clicked, we start all 5 tracks at the same time, or virtually the same time. What do we do here in the final function? Well, when a button is checked or unchecked, so on click, we call the checks function for that particular element. We find the element's ID and we turn it into a number. So we're basically getting, for the 6th value, is it 0, 1, 2, 3, or 4? We get that number. And we connect the constant source node to that particular gain, the gain associated with that number, as the gain value. So all that this is, and if it's unchecked, then we disconnect that same connection. So all we're basically doing here is the constant source node is connected to every checked source and disconnected from every unchecked source. Okay, let's see what happens. Not hearing anything because nothing is connected. So now the viola. Now I'll turn it down for a second, but notice how it changes where the timbre of the ukulele when we add in the microphone ukulele to the direct input. Okay, and that's it. That is how to use the constant source node to control multiple parameters at the same time. And it's a quite useful source node whenever doing mixing type applications, manipulating the routing, the grouping of many different audio signals. And of course, it has other uses. So, thanks again, and as always, please get in touch if you have any questions.